locked if we hold.
Coming back down for the same touch now, hopefully.
They are not seeming to care about it.
Here we go. Booster! Booster what?
They're not seeming to care about it on the tech feed, but
And
we can
Sonic
provide.
and touchdown!
iQPS's satellites are small, high-performance SAR satellites that use a lightweight, large stowable antenna to collect high-resolution images of Earth, even through clouds and adverse weather conditions. Ultimately, the iQPS constellation is planned to have 36 satellites capable of monitoring specific fixed points on Earth every 10 minutes. In addition to launching on Electron, the QPS-SAR satellite will use a Rocket Lab Motorized Lightband as its separation system for deployment into space. These satellites here will be heading into low Earth orbit today from Rocket Lab's very own launch site in New Zealand, over at Launch Complex 1B. Rocket Lab's Electron rocket is capable of carrying 320 kilograms to low Earth orbit and 200 kilos to a sun-synchronous orbit. The first stage of Electron uses 9 Rutherford engine and is 12.1 meters tall with a diameter of 1.2 meters. The second stage uses 1 Rutherford vacuum engine with a height of 24 meters and a diameter of 1.2 meters. Today's Electron launch will include the optional kick stage, which uses 1 Curie engine. This flight of Electron will not be a reusable booster today, and will be carrying a satellite with a total mass of 100 kilograms. Rocket Lab's Electron rocket produces 5,600 here we go. At sea level, the first stage produces 224.3 kilonewtons of thrust and has a specific impulse of 311 seconds. The entirety of Electron uses liquid oxygen and kerosene. It is powered entirely by batteries. During flight, you might see the during the flight, you'll see the second stage conduct what is known as a battery hot swap. And during this, you'll actually see batteries fall off of the vehicle as it switches over to another set of onboard batteries. The material used on the rocket is a carbon fiber composite. In total, the vehicle weighs 13,000 kilograms at launch. The height of the fairing is 2.5 meters with a diameter of 1.2 meters. The fairing separation system uses a pneumatic unlocking and spring combination. For stage separation, they will use a pneumatic pusher. Stage 2 has a specific impulse of 343 seconds and produces 25.8 kilonewtons of thrust. The kick stage, which will be Photon for this flight, I believe, will use a viscous liquid monopropellant as its propellant and has a maximum thrust of 0.12 kilonewton. Rocket Lab are now going live with their stuff now. Today's targeted launch is about 19 minutes away.
It's a crisp afternoon at Launch Complex 1 where Electron is preparing for its latest mission.
Let's see what it is here.
In Mahia, New Zealand. Right now it is T-minus 19 minutes in the countdown to Electron's 69.
20 minutes. All right.
Our 11th launch of the year.
20 minutes away from the targeted launch.
Operator iQPS. Good afternoon and welcome to today's launch.
If they need to, for whatever reason, they have until 5:15 UTC to launch.
Next Electron mission, launch preparations are well underway and have gone pretty smoothly throughout the count today. We're tracking no issues with the rocket, the range, or the weather in the lead up to liftoff, and the team is aiming for our launch target right at the top of today's window at 3:45 p.m. local time or 3:45 UTC. Today's launch is the fifth in a series of missions for the
Rocket Lab has flown Electron 68 times. This will be the 11th launch of Electron this year, and the 173rd orbital launch attempt of 2025.
This is named after the Japanese harvest goddess, a perfect fit for a satellite designed to help better monitor.
Electron has a current success rate of 94.1%, with 64 successful launches, 4 failures, and a success streak of 27.
Another iQPS satellite to space for them today. Now, one of the fun parts of
This will be Rocket Lab's 69th launch in total,
with each of the QPS-SAR satellites named after
as they get ready to launch Neutron in the later moments of the year.
like Tsukuyomi for the Moon God Awakens back in 2022. The remaining satellites were launched this year by Electron. Susanoo for the Lightning God Ray. Tsumi for the Seven
It's
Seas, and
looking for in the chat right now.
After today's mission, Electron
Thank you. I'm just going to call you Zen, sorry. Thank you, Zen, for the compliment there. I appreciate it.
to be launching the constellation, and we're excited.
Yes, indeed, this will definitely be one of the best. I mean, I can say that right now. We are now currently getting ready for launch. Hello, Owen. Thank you for tuning in. You are looking live at Rocket Lab's Electron rocket. this rocket flying can get today will not be attempting to be reused, and will have its first stage crash into the ocean, along with the second stage interference. Alright, looks like now they're talking about the satellite launching. Again, for those tuning in, this is going to be the 69th launch of Electron, the 11th launch of Electron this year, and the 173rd orbital launch attempt of any rocket this year. This launch will be taking place from Rocket Lab's Launch Complex 1B at the Mahia Peninsula in New Zealand. Electron stands 18 meters tall, with a liftoff thrust of 224 kilonewtons. The price of Electron is $7.5 million. A little bit of information there. This launch will be for a Japanese company called iQPS, launching the QPS-SAR 12 satellite. QPS-SAR 12 is also known as KUSHINADA-I. As we continue to count down, everything is looking good so far. As we approach the auto sequence start. Yes, indeed, Zen, I agree. Rocket Lab is very promising. Uh, yeah, Owen, yes, of course. I have the engines used on the vehicle are the engines that Electron uses are called the Rutherford engine. They are a electric turbopump fed engine. The fuel that they use, I do have that. They will use LOX and kerosene on the first two stages, while the kick stage will use a Curie engine with monopropellant. The material used on Electron is carbon fiber composite. Um, The separation system for the stages uses a pneumatic pusher, and the fairing separation system uses a pneumatic unlocking with springs. We are now 11 minutes and 56 seconds until launch. Everything continuing as planned. No, the fairing is pneumatic unlocking with springs. There's no explosives on here. Today's launch of Electron will also not be using the reusable variant. It will be going into a low Earth orbit. And Rocket Lab can put Rocket Lab can put 320 kilograms into a low Earth orbit, but today they will only be carrying 100. It also looks like now we are in a hold. I'm not 100% sure why we are in a hold, so I'll have to look over at Rocket Lab for this real quick. Yeah, I'm not seeing why they are in a hold right now, but they are in a hold right now, so. Venting is just going to be fuel. That's all it is. That's all it really ever is, unfortunately. There's nothing special going on. I believe this is typically what happens with Electron launches. Yes, Zen, I agree, actually. One of the most unique things about this rocket is the battery hot swap that they conduct during second stage flight. But yes, it does appear as though we are in a hold. They have until 5:15 a.m. UTC if they are to launch the vehicle today. These satellites here use a Rocket Lab Motorized Lightband as its separation system for deployment into space. And they will have 36 satellites in the constellation with the capability of monitoring specific fixed points on Earth every 10 minutes. These satellites here will be able to have high resolution images of Earth even through clouds and adverse weather conditions. It might be because of weather, yeah. Might very well be the reason. Let's see. What is going on? With the weather in New Zealand. Yes, Electron does get frosty. That's what the white is on the vehicle. Hello, Vulture. Welcome. Yeah. I do not know for sure. I believe the engines are 3D printed. But I'm not sure on the entirety of Electron. Yes, the Rutherford engine is fabricated largely by 3D printing. So that might have been what you were talking about. Yeah, the engines are the only thing that's really 3D printed. Yeah, the fully 3D printed one was Terran 1, which unfortunately they Relativity Space did retire that one after one launch. The other engine that will be on board today is the Curie engine, which is going to be used for the kick stage of Electron today. And that engine is also 3D printed. Can try and find that, but I don't think we'll have that. They 3D print the Rutherford engine using a method called laser powder bed fusion, and more specifically, direct metal laser solidification. Combustion chamber injectors, pumps, and main propellant valves are all 3D printed. That's about all that we have. So it does appear, though, as it does seem as though we are in a hold right now. I have currently no idea why, but yeah, that's probably true, Owen. And even then, I I'd probably not even be able to tell you everything because there might be some things that they have to keep secret. Like, for example, what CAD program they use. That might be something that is not supposed to be publicly given out. If I'm to guess, though, they might actually use their own CAD that they have developed for the Rutherford engine. But oh, that is actually cool. I did not know that SpaceX used 3D printers. Actually, I never knew that. Or I don't know if they do or not, but that's cool that they use CAD. Yeah, CAD is a good software if you want to do 3D printing and just have 3D models and stuff ready to go. I did hear that they used Python, and if I remember correctly, they also used Linux as well for the flight computers on Falcon 9. So they just added 12 minutes to the countdown. So we are now at T-minus 12 minutes and holding. Waiting for more information as we get that. Looks like we have some more venting going on here with the rocket. Python is a good programming language from what I've understood, and I think that one actually might be a bit easier to understand than assembly. But yeah. They have enough time in the launch window to keep going. They have until 5:15 a.m. to conduct a launch in the window right now. So if they need time, they might be able to have it. However, I don't know. We'll just have to wait and see. That's about a few hours from now. A couple hours, I think. I just said the time in UTC, 5:15 UTC. The launch was planned to occur 2 minutes ago at 3:50 UTC. It is a fairly short short window. Yes, I do agree, but they should be able to hopefully find time to launch in this window. If for some reason they can't, then they might target tomorrow. Yeah, I have no idea how long it takes for Electron to fuel up. What I do know though is that it looks really nice whenever it is fully fueled. Yeah, it is actually that small, yes indeed. And it does look like they released the hold. We are now back in the count, T minus 16 minutes and 34 seconds. 16 minutes, 30 seconds now. Everything is looking good now. They have found and confirmed a new T0. It's this T minus 16 now. All right. Oh. Honestly, yeah, I would agree, Vulture. Yeah, it really is very beautiful over there at the Mahia Peninsula. We have passed the T minus 15 minutes and 20-second mark. $15 to go. Then I would agree with you on that. However, um, down over in Starbase, it looks really beautiful over there too. Over in Starbase, those launch pads over there are just gorgeous. 14 minutes, 30 seconds. I mean, yeah, you're not wrong with that. $13 and 30 seconds until launch. Everything is continuing to look nominal. Rocket Lab is now targeting 4:10 a.m. UTC for the launch. 13 minutes to go. Starbase water is more cold or more warm than it is cold. But yeah. Less than 12 minutes and 30 seconds to go.
Avionics is go.
12 minutes. Looks like now they are conducting the go no go poll on the launch of Electron. Yep. Everything is go for launch. We are now 11 minutes to go. T-minus 10 minutes and 30 seconds until launch of Electron for the 69th time. Again, the Electron rocket is a two-staged vehicle with a optional third stage for precise deployment into space. "10 minutes until launch." This launch will be taking place from the Mahia Peninsula in New Zealand. "9 minutes, 30 seconds. The kick stage is the third stage, yes. Optional third stage. The purpose of the kick stage, like I said, is for precise deployment of payloads into space. Yeah.
We're almost ready to cut the ribbon on the launch site for our new reusable rocket Neutron. Our dedicated launch, test, and landing
9 minutes left. Yeah, basically. The Curry engine on the kick stage is a monopropellant engine, so it is basically like a beefed up RCS. So here they're talking about the upcoming launch pad for Neutron, it looks like. Neutron is going to be a reusable rocket that will be launched from the Wallops Island spaceport over in Virginia. And yeah. You know, Zen, what's funny is this is actually the 69th launch of Electron. So this is basically the 69th Electron vehicle. Now, there is a modified version of Electron called Haste. And Haste stands for... If I could find this real quick. HASTE stands for the Hypersonic Accelerator Suborbital Test Electron. And those ones launch from Launch Complex 2, Rocket Lab's Launch Complex 2 at the Mid-Atlantic Regional Spaceport at Wallops Island, Virginia. T-minus 7 minutes to go. I guess you could consider this the nicest Electron launch ever, Vulture. I guess you really could consider it that. We have passed the 6-minute, 30-minute mark on the launch of Electron today. This vehicle, again, will not be reused. This is a non-reusable launch of Electron. However, they are currently working on bringing Electron to reusability. You can see strong back retract. 6 minutes until launch. The strong back is currently retracting. And it has retracted. All good signs ahead of launch. Yes, Owen, it is indeed the strong back. So the strong back has been retracted. We are now past 5 minutes and 30 seconds until launch. Everything is looking good. No issues, it looks like now. Hopefully, no issues come down on the way. 5 minutes until launch. Oh boy. But yeah, 69th launch of Electron, 69th launch for Rocket Lab, 11th launch of Electron, and the 173rd orbital launch attempt of the year. 11th launch of Electron for the year, 11th launch for Rocket Lab this year as well. Past 4 minutes and 30 seconds. Yeah. There is one satellite launching on this vehicle today. Four minutes until launch. Three minutes, 30 seconds. Three minutes and 10 seconds. Three minutes. We have passed the T-minus 3 minute mark. Two minutes and 30 seconds. We are launching from the Mahia Peninsula in New Zealand. This is Rocket Lab's Electron vehicle launching for the 69th time, 11th time this year, carrying the KUSHINADA-I satellite for iQPS. T-minus 2 minutes until launch. Launch auto sequence has begun. The Electron's flight computers have taken over the countdown. We have passed 1 minute 30 seconds. T-minus 1 minute. Forty seconds.
We are T-minus 20 seconds and counting.
30 seconds.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. There's ignition and liftoff.
Stage 1 propulsion nominal.
The Harvest Goddess is on her way to space for iQPS. Electron has launched cleanly off the pad at Launch Complex 1 and is now coming up against 700 kilometers per hour in just
30
a second.
seconds into
we should
the launch.
hear from our operators that Electron
Everything
has
is
reached
continuing
max Q, which
as
is the point
planned.
in the flight when Electron is experiencing maximum aerodynamic pressure.
Vehicle is
It's the
supersonic,
first
approaching max
milestone
Q.
as we listen out for the launch. So let's bring up the audio channels now from MCC.
One minute.
Cleared max Q.
That was a nice clean pass through max Q for Electron, and we are now about a minute or so away from staging and main engine cutoff on the first stage. Now, what should happen next is that all 9 Rutherford engines on the bottom of stage 1 will shut down as planned, and just a couple of seconds or so before the
Stage
second
1
stage
guidance
is
is
released
nominal.
from its separation locks. Once we are clear of the first stage, the Rutherford engine on stage 2 will ignite to propel Electron and iQPS onward to our target altitude for this mission. Let's keep an eye out now for the view across both stages as those
Stage
events
1
take
propulsion
place.
holding nominal. Stand by for MECO in roughly 30 seconds. "15 seconds to staging. Entered burnout detect mode. MECO confirmed. Stage separation complete. Stage 2 ignition confirmed.
A clean separation from the first stage as planned, and a beautiful startup there by the Rutherford engine on the second stage. That second stage's velocity is now at more than 8,000 kilometers an hour with an altitude of 95 kilometers after that separation event. Next up will be fairing separation for Electron when the rocket's nose cone halves split and fall away to expose the KUSHINADA payload to space for the first time.
Fairing jettison confirmed.
And there you have it. Electron's
Stage
2
2
Okay.
fairing halves have jettisoned from Electron.
Sorry,
And on your screen, you'll see the
we are now
Harvest
approaching
Goddess
fairing
safely attached
separation.
to the kick stage and ready to make her debut on orbit. Taking
And
a
there
look
we
now
have
at the
clean
propulsion
fairing
monitoring camera at the
separation.
bottom of stage 2 shows that Rutherford is continuing nominally since engine startup, which happened just a few moments ago.
We have another 5 minutes to go for the second stage engine burn until the next separation event. This Rutherford engine's performance can reach up to 5,800 pounds of force in the vacuum conditions of space, with a specific impulse of 343 seconds. Now, specific impulse is a measure of performance in telling us how efficient an engine can be. One of the pretty special things about both our sea level and vacuum optimized Rutherford engines is that they're actually battery powered. The propellant pumps on these engines are driven by brushless DC motors powered by batteries. Now, since the amount of time the second stage engine needs to run is longer than the capacity of the first battery packs, Electron needs to perform a power switch over to a fresh...
Coming up next is the battery jettison. This is part of the battery hot swap that is very much unique to Electron.
In a few moments, you should hear that call out from our launch operators, and if you keep an eye out on your screen, you should see those batteries eject in the next few moments.
HQPT stretch holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
So along with the fuel on board, which is kerosene and liquid oxygen, Electron uses batteries to power its turbopump. During flight, these batteries run out, and so because of this, they have to swap out the batteries in what is called a battery hot swap.
Nice and clean with that battery hot swap there.
Keep an eye out on the
One of
screen.
Final launch milestones completed on Electron for its 69th.
And there we just saw the batteries fall off.
Now at 15,000 kilometers an hour at 220 kilometers in altitude.
A successful
Two more key
battery
events
hot
remain
swap.
for this first stage of the mission, that is SECO, or second engine cutoff, followed by stage separation, where Electron's kick stage separates from the second stage and gets ready to deploy the payload into orbit.
We're getting some stunning views of Earth from space from our onboard cameras. We touched on it a little bit at the start of the show, but right now Electron is running fully autonomously. What that means is our extremely talented GNC engineers have completed all the analysis to determine how to get to the specific place in orbit, and right now Electron's flight computer is running its algorithm in real time to...
Coming up next is the kick stage separation. The kick stage is an optional third stage for launches on Electron. The kick stage uses a Curie engine, which is a engine that uses monopropellant and is also 3D printed. The kick stage will place the satellite into a precise orbit ahead of deployment.
Electron's second stage has around 13% of propellant remaining. Much like the first stage, there's no sense in carrying dead mass to orbit, so shortly we will separate the kick stage and payload from stage 2. We are soaring now past 22,000 kilometers per hour at an altitude of 230 kilometers above Earth.
With less than a minute left on this engine burn, we're approaching SECO. The engine on your screen there will power down and shut off just a moment before the kick stage is separated into a transfer orbit. Now, it may sound simple, but this is a very precise maneuver, and it's important that the kick stage is exactly where it needs to be for the next phase of the mission. Let's listen back into Mission Control for that SECO call and stage separation confirmation.
SECO confirmed. Nominal transfer orbit achieved. Stage separation confirmed.
With that Rutherford engine cold, we have heard confirmation from Mission Control that SECO has been cleared.
There we have
and we've
good
had clean
SECO.
separation of the kick stage with the QPS-SAR 12 to a nominal transfer orbit. What that means is that the Harvest Goddess and the kick stage are on the planned trajectory to transition from this initial elliptical orbit to its final desired circular
And it would
orbit
appear
at
as if we have had
575
successful
kilometers.
kick stage
This takes
separation.
about 40 minutes or so to complete before the kick stage ignites our Curie engine to perform a circularization burn, landing us in our 575 by 575 kilometer orbit.
We'll be back with you for those final moments of the mission, but for now, you can follow the path of the Harvest Goddess in real time with our animated tracking graphic. And hey, while you're waiting, go check out the career section of our website to see how you too can make a difference in space.
We'll see you back here soon for payload deployment of QPS-SAR 12.
Checking the launch timeline. Curie ignition is expected to take place at T plus 50 minutes, 16 seconds into launch, with the shutdown expected at T plus 52 minutes and 54 seconds. This will be followed by the deployment of the QPS-SAR 12 satellite at 53 minutes, 45 seconds into the launch. Now that we have enough time, don't forget to subscribe, like, share the stream, I guess. I will be taking a break from commentary for a little bit now. Enjoy the music.